Hey, looks like we're live. It's always nice. I like this. The live word is cool. It's like you feel like you're in on stage, even though we're all in our homes. I'm excited for today's conversation. I think the three of us have definitely never done anything together, and I've known one of the two people here for a while, and we haven't had an excuse to riff on camera. So this is very exciting for me. So welcome everybody. We'll let a couple more minutes go by as people stream in, but I'll vamp. We're going to talk about a few things today. Most importantly, we're going to talk about what we call real-time events and data, how it works. We're not going to give you too much of a history lesson. We're just going to talk about the core technologies and how you can use them. The goal today is to be very focused on how this can add value to your life, whether you're a data engineer, a data scientist, revenue marketing operations team. Doesn't matter who you are. You stand to gain. You stand to make more money, and your company stands to make more money. And if you use this kind of technology, and so we're going to try to ground this very much in benefits we've seen at a variety of companies, and then we'll show you something live, so this all feels very real. And then we'll chat about all the ways this goes well, this goes badly, and of course we will make time for all the Q&A. Look, there's already chat going. This is nice. Hello everybody. So without further ado, I will kick off introductions. I will reintroduce myself in a second, but in case everyone's curious, my name's Boris, and I get to be the wonderful host today. And so what we'll do is Jeremy will introduce himself first, and as a bonus of not just introducing himself, he'll also give everybody an introduction as to what is streaming, really. What is Kafka? What is this technology as part of his intro? Take it away, Jeremy.
Thanks. Jeremy Hogan, Staff Solutions Engineer here at Confluent, just over 3 years. For those who don't know, Confluent is the company founded by the folks who developed Kafka when they were at LinkedIn. And at its core, of course, is Kafka, and we've built an entire data streaming platform around it. But the big bucket use cases are PubSub, which is how most folks probably first bump into Kafka. You can also store this stream of events in perpetuity, and you can process and analyze them either post-fact or live, real time. And so the core idea is that Kafka is this highly available, distributed, append-only log, which makes it very high throughput, low latency. And our core proposition is that we want to capture everything from everywhere, all the time, in real time, and make it available anywhere that you might need it. And this can be applied a number of different ways, which we'll get into later. Confluent has two core products. One is Confluent Cloud, which is fully managed. And, Kafka is very powerful and flexible, but it's also pretty hard. And so we've refactored Kafka to run on the cloud, and it runs on all major cloud service providers. And then we also still have a self-managed product called Confluent Platform, which runs anywhere. You're on-prem or in any of the clouds, from the Raspberry Pi to the mainframe, from the edge to the cloud.
Has anyone built a Raspberry Pi cloud? Like, is there a service I can go and just get like 1,000 Raspberry Pis?
I have a Raspberry Pi cluster. I wouldn't
really
recommend. Yeah. I wouldn't recommend it for anything useful. Because the storage. But I have a stack of about 16 Raspberry Pis that all work together as a Confluent cluster.
Neat. Very neat.
Mark, thanks, Boris. Just piggybacking on Jeremy's quick intro. So now that we have data in motion, access to all this data, and we have the opportunity not really to replace our batch workloads. That's not what we're talking about here today, but more kind of like incorporate streaming into our day-to-day business. So the bigger question is, how do you actually do that? And for me, as a former data engineer, the question is also, how do you do that without completely disrupting your team or rebuilding your whole architecture, boiling the ocean? And I Materialize, this is kind of like what we focus on, not boiling the ocean, but we want to bring you all the benefits of streaming as a technology, but maintaining, you know, the same language that you're used to, same abstraction, same ecosystem of integrations, especially important, you use with your batch data warehouse today. And our sweet spot is what we call operational workloads. And this is basically anything that requires that you have a data warehouse that is immediately responsive, is always up to date as you get new data throughout the day, and doesn't compromise on consistency with all of this. And you know, Census is the perfect partner for that. I'm super excited now that you can push events in real time to a bunch of tools that I'm pretty sure everyone here is using to support their business every day. So I'll pass it on to Boris.
Cool. Thank you. So I'm lucky to have to run this great company here called Census. We've just always been about trying to help companies use the best data they have to run their business. And for us, that means working with the data sources that people have, all the various kind of data platforms people already have in their business, and making that available seamlessly to sales, marketing, support, product, finance, you name it, right? Everyone will benefit if you can use the best data that you have. And for me, the most fun thing is, you know, there's these like various constraints historically between having really high quality data versus having high availability data versus low latency data. These have always been kind of in tension with each other. Like, for example, you know, when companies report to Wall Street, they have really good information, but that usually happens like weeks after those things happened, right? And it's because there's an army of people just like really crunching all the numbers. And anything we can do to kind of shorten that cycle can be applied to growing the business. And so that's kind of what we try to help people do is try to make all this data available and accessible and useful to business teams. And we do that with an integration platform that syncs to kind of business tools. And that's where we intersect, right? We intersect with this technology with, you know, kind of how to make it useful, actionable, versus just amazing performance. And so I think thank you both for the introduction. I think hopefully if anyone has questions, by the way, along the way that wants to understand, like, wait, I don't understand what an event stream is, or so whether it's about the technology, about the use case, or about anything we say, don't hesitate, pop it in the channel. I'll be paying attention. But I think, like we said at the top, none of this matters if you're not working on interesting, you know, kind of solutions to growing your business. And there's a lot of them, right? Jeremy, I think you know, you have this great slide here with like, this is used already in the world everywhere. And I figure we should talk about a few of these, specifically the ones like we like the most and that we've seen have the most impact. So like, Jeremy, when you think about all these, like what's the ones that come to mind, especially the ones that are the most generalizable for people, like rather than specific to one very, very narrow industry?
I think the use cases where everything used to be batch driven, you know, so you think of retail inventory management, like in the days before shopping online became the de facto route to get goods. You didn't always know what inventory was available. You had to go to the store. And if they didn't have it, you'd go to another store. But now you can go to Walmart, for example. And if I'm looking for an item at my local store and somebody's in the store and they buy it, in real time, I see that has been has been decremented. And then other things that, you know, fraud detection in capital markets. Some banks used to be in the fraud refund business, and now because they can act in the moment on real-time data, they're in fraud detection and prevention, which is a lot better customer experience.
I think that's a really interesting vein, right? Like there's a lot of things that I probably assume businesses think about as something you react to in post that you can change to be preventive in the moment, right? I mean, I guess a lot of our doctors would probably want us to behave that way.
Or even proactive things like, what do I know about this shopper over time versus what's in their cart today? Can I offer a bundle? Can I offer a loyalty incentive? What's my next best action for value while they're in the shopping cart making a moment, not just nagging them for abandoned carts, because I might have purchased it at some other store by then, and not just following on via email, but something that can get me to add 1 or 2 more items to the cart while I'm there. That's a proactive thing. That's an upsell thing.
Yeah. Yeah, I guess it's like the salesperson chasing you outside the store versus doing it while you're in it. I'm always looking for the analogies. Marta, you've kind of seen people on both these kinds of things, right? The fraud scenarios and the kind of retail scenarios. How do people think about this in terms of like, how do I think about it in terms of the value of it is personalization, or is the value of it kind of being in the flow of the event?
Yeah, I think I was gonna tie into the discussion about e-commerce, especially, is really personal to me because I used to work in a e-commerce retailer as a data warehouse engineer, deep in like old school batch world, Oracle world, and most of the days when I woke up and I was paged in the middle of the night because a query boomed, I didn't wish so much, or most of the days I didn't wish so much that things would go faster. I just wanted to be able to like distribute the load over the day rather than like have these catastrophic events that then take like another, I don't know how many hours to recover from. And I was like, I just want to be able to process my data as I get it, not so much I need to process all of this fast to do things fast. So I think there's value in both things. I think a lot of times people look at streaming like, there's like this big architectural shift, or it's operationally so much more complicated. But a lot of times there's also a lot of opportunity to simplify what you have today in batch by just processing that data as it arrives, rather than in these huge batches that then kind of like move along your pipeline and kind of can blow up at any point and then affect everything that comes after that. So I think definitely there's value in both perspectives. Like there's a slide about what I think is one of the coolest customers of Materialize, Ramp. Probably a lot of people in here use them for corporate expenses. And the cool thing is that you can see that they didn't really do a huge architectural change. So like they went from one SQL-based system to another SQL-based system, but a system that can process data as it is processed, and they can react to it when more preventively. So like fraud is not something that you want to kind of like, oh yeah, it can wait like half an hour. That's cool. You kind of want to, as soon as you have enough signs or enough signal that there is fraud happening, you want to make sure that you police the bad guys. And I think it's pretty impressive. Like if you go from, I think the slide says how hours, but I actually think that what they did was somewhere like best case, they were getting like 15 minutes and they reduced it down to like 1 second. Still writing SQL, still using DBT. So like, I think there are definitely more time sensitive use cases, but not all use cases are time sensitive. And that doesn't mean that you can't benefit from streaming as well.
I mean, Jeremy, when you talked about the kind of, well, both of you, I guess everyone can relate to e-commerce and retail. By the way, my secret reason for that is that we are all like shoppers. Like at all times, we are also all shoppers, right? And I think, one of the things, I remember having this conversation with my parents once upon a time where I think there's a lot of places where the consumer doesn't understand that why there's a delay in things. Like they don't understand distributed systems. They don't understand that there's a limit to what computers can do across a whole universe in a microsecond. Like, and wherever you can match their expectations, like things get much, much better. So it's not just the fact that you can personalize in the moment, right? Like Jeremy, you were saying, offer them the right items in their cart to increase, loyalty tied to like their preferences, right? In doing that in the moment. But it's also, I think it's almost like I know it sounds crazy, but it's like you're just meeting their expectations where they are. Like people's expectations are, you know me and you do the right thing as it happens. They don't understand that to understand you actually takes a whole takes a whole process. Yeah. Did you find that when so like Instacart is a great example of this, right? That's on the screen here. Do you remember how long it took for them to feel the improvements? Like, is this something that has like instantaneous like lift when you implement some of these things?
So in the case of somebody like Instacart, they knew they were going to be completely data driven from the start. And so luckily pre-COVID, they had already built a data streaming architecture. And during COVID, they experienced multiple years worth of growth over the course of months, but they were able to scale it because they had architected for scale. And the customer expectations that you're talking about, and that's what Marta got me thinking the same thing is, I expect if I make an update, it's going to be reflected in the system immediately. I should be able to refresh my app and see my current balance. Even if some of the transactions haven't fully processed, I expect to see that they're pending. And to your point, I think we got used to this notion that, well, they're going to debit my account immediately, but it can take 3 to 5 days to credit it. And that's just the way the world is.
Right.
And we realize that that's a legacy holdover from everything being batch driven. And banks and clearinghouses, they didn't make the update because they got away with it. Our expectation was that's just how long it takes. And that's what happens to me. But between consumer pressure and then an FSI, there's regulatory pressure. Shouldn't take 3 days for a trade to settle. It shouldn't take 3 days for ACH transfer when a wire transfer can be just as fast. That tells me that you can move money quickly. You're just choosing not to.
Yeah.
And if I know that it's a corporate choice and it's not a limitation of technology, then I'm going to demand that they make better choices.
I mean, there's that famous Jeff Bezos line, right? Like, your margin is my opportunity, because he always runs like Amazon as a, maybe we should reframe it as like, your latency is my opportunity. If mathematically I can have lower latency, that is a competitive, advantage as well, right? Like, a lot of people get lazy on this for sure. That's an interesting. I didn't know that now we're forcing it on the other side with regulations. So there you go. Maybe real time will be forced upon all of us. That might be wonderful. I don't know. We'll have to get into. Yeah, go ahead.
No, I was just gonna say, if I can compliment, I think that like one interesting thing as well of modernizing your architecture is how like different parts of the company move at different paces. Exactly to Jeremy's point. For example, in e-commerce, I worked a lot with fulfillment. And as we try to migrate from batch to streaming, there's only so much you can do when you're getting the data from your couriers on an FTP server every morning at 6 a.m. in a CSV file. So, there are things that you can have like the most sophisticated architecture. There will be parts of the business that will just take time to kind of like advance to the same level. So,
yeah, I do think one thing you said, Jeremy, that's like implicit maybe, and that we should make explicit, is regardless of latency, right? Like, there's benefits at throughput as well. So that courier example, Marta, is like really good, because you're right. Not everything in your system, like if you're Walmart, you can control probably almost every input into your system over time. But most people don't control all the inputs. But there's also the aspect of like they get spiky, right? Like you get that spike in arrival of data, and you want something that can always handle that, even if at most of the time it's not like receiving a deluge in real time. So I like that this architecture, like using these kinds of tools, sets you up for either of those things, like kind of with the same consistency. Heck, actually, I have a scenario, like I've seen a few companies have, this is, to me, it's illustrative of this. Not everyone's going to be like an e-commerce company or think about fraud, but I was chatting with companies that do like fantasy sports type stuff, right? So it's like it's gambling-esque, but not quite. I don't know what you want to call it in today's world. These two are definitely kind of on the spectrum. But the key here is that like everything happens in a very short time frame, where like 30 seconds before the end of a thing, suddenly like you have to be able to operate at extremely low latency, and then it goes back and calms down, right? Like it's like, I don't know, like the horse race is about to end or something. And there it's like non-negotiable. Like you don't have a product experience if you're not able to operate in near real time, if not literally real time, which has very real consequences. So like I think that this is where it's like spikiness is also kind of something that you can solve for using this technology, which is neat to me. Okay. All right. Well, before we get, so one of the things I wanted to talk about today is like all the ways this like gets used in practice and like how it goes wrong and all these things. Hopefully this entices people so far, but I think my biggest view from this, having been around, you two have probably spent more time in it than I have by quite a margin. But I've been like, let's call it Kafka adjacent for 7-something years. And this is something that I find most sophisticated companies understand already. It's something their engineering teams have factored into their process. It's the other companies that I find that the slightly lower scale companies where they do this very poorly. They do it with silos. They do it with, they don't have this kind of stack. And part of that to me is because it's pretty hard to manage this. And so I figured we should do let's make this real. And Marta, you've prepped a demo of how this can be used in practice without kind of like rocket science. And I think that would be helpful. And then we can get into all the ways that this goes wrong.
Cool. Thanks, Boris. All right. So yeah, thankfully, thanks, Boris, for not making us look at slides a lot. Yeah, so I was exactly not sure, having been on like both spectrums of like extreme batch and extreme streaming. I'm never sure how proficient folks are here. So I went pretty bare bones with a demo, picked a use case that just tries to make me an online shop owner less sad about how inefficient my inventory management is. So something I'd like to do here, or like to improve, is reduce the chance of people coming into my online store and not being able to buy products they want because they're frequently sold out. And at the same time, I look around and there is overstock for other products that I never sell. And at the same time, it'd be great if I could solve this in a way that doesn't involve customers losing trust in me and my store. Like, I could just start lying about the expected shipping date for sold out products when in fact I have no clue when I'm going to get a restock for them. So my plan is to tick the box in my Shopify online store that says, if the product is sold out, you can go ahead and keep selling it. But what I want to do then, instead of just like straight out lying about shipping dates and making them up, I want to make sure that when I get an order that qualifies as having items that I don't have in stock, I want to make sure that I immediately take note of the amount of items that I'm missing and their SKUs. And I want to immediately place an order with my supplier and get like their estimated date for fulfillment. And two, with that information, what I want to do is trigger an email to the customer with that is enriched with an accurate estimate, instead of just being oh, hey, thanks for buying this. You'll be hearing it from us in possibly 1 month to 6 months, like it happens sometimes. And maybe I want to send them out a discount for next
time.
You're
giving me a Kickstarter flashbacks.
To maybe like give them a discount as a way to say sorry for the inconvenience. So from a technical standpoint, like Boris said, I wanted to kind of like make this really as simple as possible. I mentioned in the slide above that, if we're talking about, depending on your requisite requirements in like the real world, if you want durability, if you want like the scale ingest, you probably, you might want to use something like Kafka, but here, I'm just trying to simplify this to like the people who are not maybe ready for like a full-blown streaming architecture. It's kind of like the SQL induction to streaming, the things that you can do with kind of like everyday data tools. So from a technical perspective, what this looks like is I've set up a couple of webhooks on Shopify, and these webhooks will trigger events when anyone places an order in my shop. These events will be sent directly to Materialize, and what Materialize does here is just like all the SQL wrangling, joining these events together, doing some transformations to, in the end, calculate or like identify, does this order have items that are not in stock or not? And then what Materialize will do is just like push these orders, and only these orders that have like oversold items, through to Census. And now that Census has live syncs and can just kind of like listen to data and shoot events out as well, Census will just route that to Braze and send whoever the affected customer is a targeted email. I, of course, underestimated how much work processing real world data requires, especially when I have to massage it through like 4 different SaaS tools. So I'm only going to show you the email flow in action. There's not a lot of personalization going on, but these are like all things that you could build easily, especially if you know what you're doing with tools like Braze, which kind of like go over my head, ironically. So, fingers crossed. And this is not what I want to do. Okay, so I have Shopify. I'm sure everyone is familiar with it. This is where I'm hosting my store. And Shopify allows you to define webhooks. And in my shop, I have like, whenever someone places a order, I have Shopify send a webhook event to Materialize for order creation. And at the same time, it also triggers an inventory level update that will let me know for this item what is the remaining stock after this purchase. And this is my store. It's selling snowboards because that's what Shopify...
Toby this will never change.
They had this out of the box. And I very conveniently have a out of stock snowboard that, if you see in the back end, is down to -5. So like I completely do not have the out of stock snowboard in stock. And then what will happen, what we'll use Materialize for, I've defined in Materialize a couple of, actually, if you saw the links here for the webhooks, they are just like callbacks for the 2 sources that I have running here that are accepting webhook events from Shopify. And then in Materialize, I just defined like a couple of Materialize views. There's a lot of just like, these cleaning and like untangling of like horrible JSON payloads that you don't need to see. But if you're wondering like why should I care about a Materialize view? What does this do? Basically, when you get an order coming in from Shopify, if you want to know, for example, like how many items, like you want to have a running count of the items that are unavailable for each vendor, you don't want to manually run this query every time. And if you create a Materialize view embedding this query, what it will do is maintain this statement or the results here up to date for you without you needing to schedule anything or anything like that. And if we select from it, Materialize is just like normal SQL. I hope I still know how to write SQL. Yes. You will see that we'll have a count of 6. When I click to buy something in Shopify, this will increment automatically. And the same will be true for my Materialize view that is just tracking, what are the orders that are coming in that have items that we don't have. And these are like all my desperate tests as I try to make this demo work. And this is how we reached -5 for our out of stock snowboard. And so this materialized view is what then, in Census basically we connect Census to Materialize and say, hey, I want to send you events from this Materialized instance, and I want you to send those events to Braze, which is, like I mentioned before, a customer engaging platform that will allow us eventually to send out an email. And so what you do in Census, you create a sync and you say, hey, for my stock out orders, Materialized view, whenever something comes in, so like when we have a new order number in that Materialized view, can you please trigger an event to Braze? And this will be running continuously, which I don't know how many people in the audience are familiar with Census, probably a lot, but we had like the first version of the Census integration where things were batched. And of course, like it doesn't have the same power as what you will see now. So like if I use the batch-based integration, the customer would get a email in like 5 minutes. And now when I click it, I will barely have time to switch windows before you see the email coming through. And then we have Braze. It's a very marketing focused tool. But what I did in Braze is just like define a campaign that says, hey, when Census sends you something, it means that a customer bought something that is not in stock. Can you please send this very specific email to just that customer? And of course, here's where you can do like all the personalization with segments and audiences and all these things I do not understand. And yeah, that's basically kind of like the gist of it. We have 4 tools. So what I'm going to do now, I'm going to go on my store. I'm going to place an order for my out of stock snowboard. And what I expect to happen is Shopify will send out the events to Materialize. Materialize will identify this order as an order that contains an item that we cannot fulfill. And so it will push it out to Census. Census will send me an email through Braze saying, hey, something went wrong and we're really sorry. All right. So I'm just gonna buy a snowboard out of my own shop.
Here comes the credit card fraud.
All right. Cool. So a few things that we're gonna check, like the full pipeline goes a bit fast, but if you notice the time when I click the pay now button, you should be able to trace it back to the time I will get eventually my emails in my inbox, because I want to show kind of like in each tool how this flows through. So I'm placing my order. In Materialize, what should have happened is in my purchase orders, this should be now 7, hopefully. All right. And same for my stock out orders. So I should have another order here with another snowboard that we can fulfill. And this is my customer ID. This is what you see here. We had like 3 successful events that passed through Census. There are now 4, which means the event was processed correctly. And now if I switch to my email client, which hopefully does not have any embarrassing emails in it, you will see that I first got at 33, I got something you can't disable in Shopify, which is, oh, your order is confirmed. And then I immediately got personalized email that I did in Braze.
You're in a different window, Martha, right?
Oh, yes. Oh, no.
It's all good.
I'll just show it on my phone. It's probably easier. Okay. Okay. Can you see my phone?
Yeah.
Okay. So I have my confirmation from Shopify, and then I have an email that says, oh, bummer. It looks like your shipment is going to be a little late. And then we're sending them a 10% discount, just saying, yeah, we're so sorry, you can claim a discount. If you click on it, it goes to a Rickroll video on YouTube, but that's as far as I got. But hopefully like this gives you the gist of how we kind of like put together a couple of like non-super complicated tools, probably tools that you already use, and you can build like a nice little flow that has like super low latency end-to-end. And that could help me as a shop owner be a better person with my inventory tracking.
Yeah, I think it's neat to see, right? Like the fundamental technology underpinning all this is Kafka, and it's neat to see that. I mean, it's fun to try to demo this, right? Because it's like things happen almost each one. It happens before the tab switches, right? Which is kind of fun. But I personally think like what's exciting for me and is that now I think a lot more companies can try this, can try to get to this level of customer experience long before they would have in the past. And Jeremy, I think like you said two things that I wanted to click on, right? One is like the core idea of PubSub, right? Is that it almost separates the concerns. It's like we move at high velocity, but each side doesn't have to think about the other. So in Marta's example, like the marketer is actually sitting in Braze and they get to design that email. They get to decide what the coupon should be. They get to decide, you know, whether it should have this kind of vibe or this kind of vibe. Like all that stuff is their decision. And they don't have to worry about anything except like receiving the triggers, which the kind of the data organization can do. And then in the middle, right, like someone might decide that out of stock, the meaning of out of stock changes. Well, it's like, we actually have a buffer, etc. And then at the source, it's like, well, you just got to generate the purchase orders, right? Like that's your job. And the thing that I'm curious about from someone who has seen, like you have actually worked with companies at all the scales, including the very high scales, who basically do these things. So what, like once you get on this path, like what are the things at a high level that go wrong?
So the good thing that you hit on is that once you decouple producers and consumers, you don't have these point-to-point connections all over the place, right? And you've gotten rid of like getting secondhand information from a chain of applications, and that's good. But the problem that introduces is data governance concerns. So anything from like GDPR to California CPA, cross-border data compliance, PII, all of those kind of things. But you want to know how to, you know, I'm getting the most timely data, the most accurate data. And then the third concern, am I even allowed to see it? And if I'm requesting access to data in a firm, I might not know what those regulations are. That's up to the data owner to know.
Right.
And so you don't want a free for all where here's a stream and it's got all the customer data, but accidentally some front desk banking application can see personal information and financial information, which they should never be able to see at the same time, right? And so one of the cool features that Confluent has is this data portal, and I described it a little bit to Gloria in chat, which is you should be able to visually track where is the data sourced from, where has it been enriched and enhanced along the way, what does a message look like, and then if that looks like my stream in the data portal, you can request access so it becomes data as a product kind of a service. And then as a data owner, I can say, yes, you can see that, but you can't see these three fields. So, you know, then I can decide, do I want to, you know, redact or mask or tokenize or even encrypt that field so such that I don't break the application. Like it's expecting a field that has 16 characters in it, but I can't give your actual account numbers. So I tokenize it and I just give you 16 characters. Or I need to encrypt it and you need to have the key to decrypt it on the fly and all of those kind of things. When I was at Citi, if I had a tool like that, and in my group, most things were run on Kafka, it would have changed the onboarding of all of our internal applications and desks from weeks to minutes to do something like that. Because, you know, am I using the right schema? If I make a change to the schema, can I make sure that it doesn't break anything going forward, and all of those kind of things. On top of data governance concerns with regulations are things that you're going to want to control. And I think that that's probably one of the bigger things you bump into is like data used to be hoarded because it was easier to just hoard it than it was to explain all of these regulations. And it's still easier to control it at the source than it is to explain what the regulations are to every person that might request it.
I think, oh, go ahead.
No, go ahead.
Horst.
No.
No, I was just gonna say that I think that one really interesting thing, like if you look at Confluent and like how like data governance for streaming is not, it is a very recent thing. So I think there's a really interesting, is dichotomy a word you can use on a live stream? I don't know. But you know, you have like the people on the side of like databases. You know, in databases, no one thinks about RBAC, no one thinks about things like row level security. You know, there are things that are just like taken for granted. It's just like, you know, you don't even know they're there until something is weird. Or you have a DBA, and the DBA is the person that needs to worry about all of those things. And on the other hand, you have like, historically, you've had like very little best practices, things like, you know, deployment, CI/CD, like this sort of like software practices that decrease the risk in streaming because they're like so widespread. I think that's where it increases the risk on like the batch side, and the streaming, it's the other way around. So like data governance is like kind of like a given in the database world, and when you go to streaming, that's kind of like the part that is still in motion and that is still like so hard to do. Something like similar to RBAC, right? It's like something that is incredibly hard to solve for in streaming.
Yeah.
And that's something that's cool about Materialize, because they do materialized views, which means you can still have one data stream. You don't have to over replicate to give some subset of every single stream to every single customer or internal or external that you might have. You can present a materialized view of just what they need that's still sourced from a single stream. So you control your data sprawl that way as well.
The thing I was going to ask, I could not agree more, right? This is always the, you know, there's two comments that are just perfect in here, right? Which is like, who's in charge of the governance, the producer, the consumer, who's going to have the rules, right? There's always the like, who is the trusted oracle to tell me what the rules are is a kind of a perennial problem in this kind of, when the concerns are separated. But I'm curious if you two have seen, like, one of the things that I've watched, right, is we make it possible as a product, right, for business teams to get access to what's in the database, right? So whether that's the marketer doing stuff in Braze or the sales team doing stuff in Salesforce, doesn't matter. And you know, there's interesting little subtleties around data types and understanding like kind of the meaning of things, the semantics of things. And one of the things, for example, that gets people tripped up is uniqueness of a record versus not. Like people are very laissez-faire about those things in the real world, and in systems we need those things to be very tightly defined, right? So I'm curious with streaming, how do people, especially when you go outside the inner core of like an engineer using this with another engineer to publish and subscribe to data, how do you kind of help them get over the problems that occur with like understanding the concepts of like Atmos once delivery or you know, retrying you know, in a dead letter queue? Like how do people avoid those mistakes, or how do they navigate those kinds of that learning curve? Because when you do things in real time, right, like that email is going to go out, like, and so now you have new problems, right, around, oops, that was the wrong email. And multiply that by 1,000. That was the wrong fraud detection. We detected incorrectly. Is there any tips for how to, like, for me, it's either you're going to get in trouble or you just need to build that in up front as a, like, mistakes are going to be part of the system. That's a tough one.
Yeah. I think like related to my my previous answer, like for example, something that even in batch was extremely hard, just like how do you unit test SQL? No one has like a great response for that. I mean, it's coming, and DBT is going to have something soon, but you know, and this is something that in streaming is more preventable, because like you have so many steps of just like software engineering kind of like practices that kind of like avoid a lot of these mistakes. But then like I think consistency is a great point to go into, because it's another thing that, like, if you come from the database world, did you ever think if your Oracle database was consistent? It's like something that I never really thought about. But as you move to streaming, you're just like, there are consequences to emitting intermediate results instead of just like when you have the full view of the data that you process. So it's really tricky, but in the end, like I'm sure that like Jeremy has way more context with different levels of how much do you have to care about correctness. Like there are some use cases that are like higher correctness requirements. There are other use cases that can survive with oh, you sent like a duplicate, and we can survive that.
Yeah, I think we historically have had to tap into where the customers are. So folks on big legacy databases, they do understand the notion of eventual consistency, because that's where these batch jobs that are refreshing or reconciling databases across the firm at the end of the day come from. And you can segue into, well, in delivery semantics, we call that exactly once or effectively once semantics. You can achieve eventual consistency in real time at the same time. And then there's another core group of customers that understand messaging, like they have MQ or they have TIBCO or some event streaming bus. And so they do understand delivery semantics. And we just talk about, how we handle delivery semantics. And some of them, you're educating them on real time, and you're introducing these terms. It's like, here's a problem that real time is going to introduce. Your older, slower databases might be producing data that gets acted on that goes off to the cloud or something like that. Well, how does that come back? You have to eventually reconcile. Do you wait for a batch job to come in and just stomp on all of your intraday stuff and now you're reverting to yesterday's activity? No, you want to have some sort of a write back that goes to the original source, reconciles it there. So when they still do their batch jobs, they aren't recreating this data drift that you've fixed with all your intraday activity. In the early days of Confluent, we were educating customers on this whole glossary of terms. And I think Boris said it, like, now we take it for granted that Kafka is used all over the place, for example, and that they understand that this is necessary to build an event architecture. And now we're elevating it to, okay, now what are all of the things you could do with it? Now that they understand that everything that happens in the firm, you can call it an event. What can you do if you could assemble all of those into different states and different materialized views and into different streams and processes that were effectively autonomous, but still trustworthy?
You actually said something there that I think is subtle but significant, which is databases give you the illusion that you will avoid these mistakes. But you could still have a query that has a mistake, and then you will have acted on it. And then by the time you find out, it's actually just like days have gone by because of the way those systems are designed. And then you just have to fix it at that point in time. And you have this illusion with real time. I think that with streaming, the key is here. Let's not hide it. Like, those things are going to be made very obvious much sooner, right? Like, because that bad kind of trade or the bad email, either one of those extremes, right, is going to happen right away. And then people are going to get angry right away. But you just have to solve it. You have to solve those problems at some point anyway. This just kind of forces you into solving that, whether that's with defense in depth or some business solution to the idea that, like, yes, sometimes we will send a coupon code that we didn't mean to, or that we will make a trade that we didn't mean to. And you just have to, like, you're going to have to solve it at some point. And arguably you can solve it better from a user experience perspective if you have like a kind of streaming consistency model versus a batch consistency model. That doesn't mean it's easy though. I have found that this is where a lot of people don't think this through. Like this is, and they often, what I found, Jeremy, is that like, this is what stops the broader world from using this kind of technology, because it makes apparent the mistakes they will make much more loudly.
Right. Well, the cool thing, one of the things I liked about Kafka over, say, Tibco or RabbitMQ is once the event is fetched, it's still there. So if something goes wrong, you can go back and say, give me a tumbling window of activity, or tell me everything that was going on in this customer account on Wednesday from 3 to 5. And so the auditability allows you to deploy with more confidence, because if something goes wrong, you can go back and quickly unravel it, versus in prior regimes, you just had to wait for the big batch job to come. And so, yeah, maybe I lost 3 days worth of activity, but at least I'm at the last known correct point in time. And that was a trade-off you were willing to make, right? But now, as long as you can show the flow of data, what happened to it, and I can identify, well, it's being enriched with a field that the consumer shouldn't see, or it's missing a field that they need to see in order to act on, or it's never getting written back to the source, so the source every night is stepping on everything that's happened intraday. That auditability and that observability is key.
Yeah, I do think that definitely, like, correcting mistakes, like the mistakes you can do in streaming are potentially more dangerous, but also, like, I do think that it's harder to course correct something you did wrong in streaming than what you did in batch. In batch, you just rerun like your huge batch job with 10 hours and then like it's done. And in streaming is like backfilling historical data is like a whole topic. So it's actually very non-trivial to fix mistakes you do on the streaming side. So I think again that like it helps that you have, in some way you do have like some more guardrails, because like, especially if you're not using a SQL abstraction, like and you're just writing like Java or Scala, like there's so many testing and
Right.
things you can do to prevent things that in SQL is just like, I don't know, is this left join just like completely gonna like go crazy when we receive this one row that we've never seen in like 10 years? Who knows? I guess when that happens, we'll find out.
And I think you're pointing out there's still a good use case for batch as a reconciliation process, because when I think of mainframe integrations, which is a hot button for us recently, the data is always flowing off, but then how does it get back on the mainframe? Because a lot of times the mainframe copy of the data is still the single source of truth. And sometimes it doesn't. Sometimes they're just like, we've done our rollbacks, everything locally on the mainframe, so you'll just have to wait for the nightly batch job to be consistent, and that's the only way to correct any error that might have happened. Hopefully the opportunities you create with that intraday activity are greater than the costs of the occasional mistake that you might have to overwrite. That's not a new problem. That's a problem that existed in the batch only universe, is that you would have to wait to the end of the day for everything to get corrected. And if we've reduced that to a small percentage, well, we're just going to have, because you're always going to have to reconcile. You're always going to have to refresh and rehydrate, right? So
you say that, Jeremy, but actually we were just having this conversation at the office a week ago, and I don't think that's a well understood idea by kind of, again, the broader universe, that like, you should have things be incremental, streamed, etc. Right? You should have almost everything in your world should be on a, let's call it a change data capture kind of approach, right? But it is actually like, software is, this is going to sound bad because we work in the software business, but it is like not ever going to be 100%. Like there's no such thing. And so the right answer is, on some reasonable cadence, whether that's, once upon a time, it was like probably monthly. And then you hopefully back that into all the way down to like sub day, you should have a reconciliation refresh process. And if you design for that, you will actually have all these things resolved. And now you can just focus on like reducing the length of time in which things are unreconciled. And I think that is the lesson I would impart on people. Like, you're going to have to resolve this at some point, and you should just build that in. Make it slow first, and then make it faster as you go. Right. By the way, Martha, you said this, like, some mistakes, if you're in batch, actually are worse, funny enough, because time will have gone by with the mistake in play. And then I'll give you really something very far away from like what we've talked about today. But like, you can sync stuff into a CRM, right? And so like salespeople will get, there's a new deal, there's a new opportunity because like so-and-so in our tool has used all these capabilities. And they start working on it. They put notes in it. And then you're like, oops, turns out it was related to a domain or an account that was already in existence. Now we got to remerge them. But now a day went by, people started writing human stuff in there. Now you have merge conflict that is like not machine solvable, basically. Now you have a human process you're forced into, let alone if there's auditing requirements on the on the other side, on the finance side. But it's like, that to me is like, if you can shorten that, you might actually find no merge conflict. You might be able to just resolve, which is huge.
Yeah, I mean, I remember like the bane of my existence was monthly closing, and I was like, why are we, like, most of the things, like, you have daily data for these things, like, why are we calculating like this? And every single like every month it would fail, and the stakeholders would be like, where's my data? And it's just like, oh, we need like 12 hours to actually like get you every
right?
month.
Like, Jeremy, you said this earlier, like there's banks that do 3 to 5 days and they don't need to. Like, we know technologically they're not forced to. Don't get, like, accountants are going to get angry at me, but like monthly close shouldn't be a thing. Like, there should, like, that is an artificial time is a construct, and there's no such thing as like a 30-day, like, we must wait until the end of the month. Like, yeah, someday the world will.
That should just be like some sort of a timestamp meta level thing. Your data should be up to date monthly. And to Martha's point, quarterly too. Same thing. You would just crush all of our systems all at once with these quarterly reports, and you've already got the data. And it'd be better if we could just give you the 2% delta that you might be missing.
Totally.
Yeah. Also, because then when the numbers don't match, it's like, where do you even start?
Well, and do you remember
backtracking?
You wrangle the teams again, right? It's like an excavation process at that point. Whereas, if you did it like within 48 hours, probably would be resolvable so fast. But
and then it's like a comma in like the operational post.
The accounting industrial complex. I think we're going to fight that some other day. Listen, both of you, thank you so much for doing this. We hopefully we'll do this again, and maybe in the real world someday. And feel free to email us questions after and post if people didn't get to ask questions live, and we'll keep talking about how to get more people to stream. Thanks again.
Awesome. Thanks, everyone.